Chapter Earthquakes. Let's see what we are going to cover in this chapter. In this chapter, your syllabus has 6 main answers, ranging from meaning of earthquakes, causes of earthquakes, how to measure an earthquake, that is, measurement of earthquakes. Just like the previous chapter of volcanoes, here also you have effects which are destructive and constructive, and earthquake zones of the world where you find earthquakes and where do earthquakes occur. In this chapter as well, you have examples to be learned, names of earthquakes, places where earthquakes have occurred, and picture studies can come from this chapter as well. Let's see the first question. What is an earthquake? And give an example. Here you have two answers. You can choose any one, whichever is preferable, whichever is easy for you to learn. Let's go through them. An earthquake is a sudden displacement of a part of the Earth's crust. A sudden displacement of a part of a Earth's crust occurring when two blocks of the Earth suddenly slip past one another due to tectonic forces. So these two blocks of the Earth suddenly slip past each other due to tectonic forces. This is your first meaning. What is an earthquake? It is a sudden displacement of the part of a Earth's crust occurring when two blocks of the Earth suddenly slip past one another due to tectonic forces. Basically, the Earth is shifting and the crust of the Earth is cracking. Moving to the second meaning, an earthquake is defined as a tremor below the surface of the Earth. So it is a tremor, it is the shaking of the Earth which occurs below the surface of the Earth, which causes the shaking of the crust. These devastating tremors are caused by stresses that breaks the Earth's crust. Revising the second meaning, it is defined as a tremor which has occurred below the surface of the Earth, which causes the shaking of the crust in turn. These devastating tremors are caused because of stresses that break the Earth's crust. These are stresses which breaks the Earth's crust. Moving to the second answer, causes of an earthquake. Here we'll be covering 4 causes with examples. These are from question number 2 to 6. Moving to question number 2, state 2 causes. State 2 natural causes of an earthquake, volcanoes and plate tectonics. 2 natural causes of an earthquake are volcanoes and plate tectonics. We will be seeing each one in detail. Let's see, how does volcanoes be a cause of an earthquake? Give an example. Or, this is a very important question, please make a note of this. If they don't want to ask you how volcanoes cause an earthquake, they may ask you this question, that is, volcanic activities. Please make an important note of this. Volcanic activities and seismic occurrences, that is, earthquakes, are interrelated. Volcanoes and earthquakes are interrelated. Give reason. Let's see what does the answer say. Volcanic eruptions are the main causes of earthquakes. During volcanic eruptions, hot gases are pushed upwards. Hot gases are released which go upwards. And these gases push violently the Earth's crust also upwards. So hot gases are released upwards. As a result, what is happening? They are pushing the Earth's crust also upwards, causing earthquakes. Volcanic activities and earthquakes are interrelated, and an earthquake follows a volcanic eruption, or a volcanic eruption may follow an earthquake. Revising once again what we learned, volcanic activities and earthquakes are interrelated. Why? Because during a volcanic activity, hot gases are pushed upwards. Here is the image, hot gases are pushed upwards. As a result, they push violently the Earth's crust, causing an earthquake. When hot gases are pushed upwards, they push violently the Earth's crust also upwards, causing an earthquake. That's why earthquakes and volcanoes are interrelated, and an earthquake may follow a volcano or vice versa. Let's see an example. The violent eruption of the Krakatoa volcano, here it is, photo of the Krakatoa volcano, between the islands of Java and Sumatra caused severe earthquakes around a vast region. The earthquake generated a tsunami which killed about 30,000 people in Java and Sumatra. The eruption of the Krakatoa volcano caused earthquakes in the Java and Sumatra islands. As a result, the earthquake generated a tsunami. So volcano happened, earthquake generated a tsunami, which in turn killed 30,000 people in Java and Sumatra islands. Moving to the next cause, question number 4. Explain how plate tectonics cause an earthquake with the help of an example. This plate tectonics point you've already done in the previous chapter of volcanoes. This is exactly repeated from there. Let's say, what does it say? Because the previous answer also said the same thing. Earthquakes and volcanoes are interrelated. So the causes are also same. That is, the plate tectonics cause is exactly the same. According to the plate tectonic theory, the Earth's crust is made up of a series of movable plates. These plates move and slide past each other. These plates move and slide past over each other. They slide past against each other or over each other. Most earthquakes occur on account of plate movements. When two plates slip past each other or collide against each other, their edges produces faults along the line of weakness. Their edges produces faults along the line of weakness. The tectonic earthquakes are most frequent. These earthquakes are immensely powerful. They occur in high risk areas or high risk regions. Which are they? These are the Pacific Ring of Southeast Asia, that is Philippines and Indonesia, and northern India along plate boundaries. Where do they occur? Pacific Ring of Southeast Asia, that is Philippines and Indonesia and northern India, mainly along plate boundaries. Example is here. Example in India, a severe earthquake occurred in Bhuj in Gujarat in 2001. Where 2001 Bhuj in Gujarat, a severe earthquake occurred due to the lowering of the Indian plate below the Asiatic plate. Due to the lowering of the Indian plate below the Asiatic plate. Moving to the next cause, folding and faulting. Question number 5. Explain how folding and faulting causes an earthquake with the help of an example. Internal, horizontal and vertical movements. Internal, horizontal or vertical movements due to compressional and tension forces. Which are the words? Compressional and tension forces causes folding and faulting in the Earth's crust. So these are revising the 4 keywords. They are internal, they are horizontal, vertical movements, they are compressional and tensional forces which causes the folding and faulting of the Earth's crust. 5 keywords. These causes displacement of rocks in the Earth's crust. Such an imbalance causes an earthquake. Here you have some images of horizontal, vertical movements, different types of faults which cause an earthquake. So internal, horizontal, vertical, compressional and tensional forces causes folding and faulting. When this causes displacement of the rocks inside the Earth's crust. As a result, an imbalance is caused, causing an earthquake. Example, 1906, the San Andreas Fault of California, USA. Here is an example. San Andreas Fault of California, USA gave a rise to a major earthquake that measured 8.3 on the Richter scale, which is a huge earthquake. 8.3 on the Richter scale and broke the Earth's surface along 402 kilometers length long. It broke the Earth's surface 402 kilometers length long. This is how folding and faulting causes an earthquake. Moving to the final cause of earthquakes, state 2, man-made causes which causes earthquakes. Let's see man-made causes with examples. Human activities like construction of dams, nuclear explosions, blasting of rocks, mines, etc. near faulty zones are all responsible for causing earthquakes. There are two examples. Let's see the first one. Koyna earthquake in Maharashtra was caused because of the construction of the Koyna Dam in a seismically active region. Here is a photo of the Koyna Dam. There's one more example. The second one, chemical waste dumped into the ground and underground explosions in USA caused several earthquakes in Colorado in 1960s. So one is an Indian example, the Koyna earthquake, Maharashtra, because of the Koyna Dam. Second is an international example, USA, Colorado, 1960s, due to chemical waste being dumped into the ground or underground. Moving to the next answer, anatomy of an earthquake. Here it is between question number 7 and 8, two questions. You'll be covering three types of waves, each in detail: primary waves, secondary waves, and long waves. And then we'll be covering two important concepts: seismic focus and epicenter. Moving to anatomy of an earthquake, question number 7. Explain the three types of waves of an earthquake. The answer says the tension caused by the movement of the Earth's plates built up until it is released in the form of powerful vibrations. So what happens? The tension under the Earth's surface is building up because of the movement of the plates, and then it comes out in the form of powerful vibrations. These vibrations travel in three types of waves. Which are they? Let's see. These vibrations travel in three types of waves, namely P waves, S waves, and L waves, which are long waves. These waves move outwards from the focus. These waves move in outward direction from the focus and can travel through in both directions, that is, can travel in the horizontal and vertical planes. As we said, these powerful vibrations come out in three types of waves. Let's see each type of wave in detail. First one, primary waves. They are the first to be recorded. These waves are the first to be recorded on a seismogram of an earthquake. Second type of waves, S waves, that is secondary or shear waves, as we said. As the name says, primary comes first. So primary waves are the first to be recorded on a seismogram. They are the first earthquake waves. The secondary or shear waves are after primary waves. They are the second to be recorded on a seismogram. And finally, third type of waves are the L waves, long waves or surface waves. These waves travel along the surface of the earth and are recorded after the P and the S waves. So primary first, secondary second, L or surface waves third. These L waves or the surface waves are last to arrive. Moving to the next point, how these waves travel. P waves, let's see how P waves travel. These are compressional waves. They are compressional waves, that is, they vibrate in the direction of the movement of the wave, similar to a sound wave. Once again, they are compressional waves, that is, the particles vibrate in the direction of the movement of the wave, similar to a sound wave. Here you have an image. These travel similar to a sound wave, just like the spring is compressed. It also says, once again revising, the particles vibrate in the direction of the movement. Continuing the second one, S waves. They are distortional waves. They are distortional waves in which particles vibrate at right angles to the direction of the movement of the wave. Here is a photo. S waves are distortional waves. The particles vibrate at right angles to the direction of the movement of the wave. Here is one more image of S wave traveling like this. The particles vibrate at the right angles to the direction of the movement of the wave. There is no movement given regarding L or surface waves in your syllabus. Moving to the third point regarding anatomy of an earthquake, that is these waves. P waves pass through solid, liquid, and gases. The P waves pass through solid, liquid, and gases. The P and the S waves travel through the interior of the earth. S or secondary or shear waves, they cannot be transmitted through liquids. S waves travel in the interior of the earth but cannot pass through or cannot be transmitted through liquids. It is these waves that make the inhabitants of the earth feel the ground motion. So it is because of your S waves we feel the earthquakes. It is because of these waves that the inhabitants of the earth, that is the people living on the earth, feel the ground motion. That is the movement of the earth. And finally, long or surface waves. These are two types. There are two types of L waves which are identified as love waves and Rayleigh waves. Going to question number 8 under anatomy. Here we learn about two important concepts, seismic focus and epicenter. Let's see what is the seismic focus, the point of origin of these waves, that is the seismic waves, is called as the seismic focus. Basically, in simple words, the point of origin of the earthquake. The point of origin of the earthquake is the seismic focus. Most of the earthquakes have their seismic focus between 8 to 35 kilometers in depth, which is usually under the ground, 8 to 35 kilometers in depth. Next concept is epicenter, the point on the surface of the earth directly above the seismic focus. That point on the surface of the earth directly above the seismic focus is called as the epicenter. So here is your seismic focus, here is your epicenter when you straight go up. Moving to the next answer, measurement of earthquakes. It's from question number 9 to 12. Name the instruments and scales used to measure an earthquake. We'll be covering one instrument, that is the seismograph, in detail, and two scales, that is the Richter scale and Mercalli scale. These are there. These are the three things to measure earthquakes in your syllabus. They are used for measuring the direction and intensity of an earthquake. Question number 10. Explain seismograph as a tool to measure earthquakes. Here you have a picture of a seismograph. Let's see how does the seismograph work. The instrument seismograph is used to measure the intensity of an earthquake, and the recordings are known as seismograms. These recordings are known as seismograms, and seismograph is the instrument used to measure the intensity of an earthquake. The direction of movement of waves and their passage at a particular point is also recorded by a seismograph. The direction of movement of waves and their passage at a particular point is recorded by a seismograph. And the second last point there, the seismograph has a pen attached to it. Here is your pen attached to it. Seismograph has a pen attached to it, which vibrates with the earthquake waves recording their movements on a traveling strip of paper. So the seismograph has a pen, and the pen vibrates with the earthquake waves recording their movements on a traveling strip of paper. Final point there, it also calculates the difference between the arrival in the P and the S waves. This interval is then used to calculate the difference between the recording station and the epicenter. So the final point says it also calculates the difference between the arrival of the P waves, that is the primary waves, and the S waves, which we did. This interval is then used to calculate the difference between the recording center and the epicenter, that is where the earthquake has occurred. and the recording center, that is how far is the seismograph kept. Moving to the second measurement of earthquakes, question number 11, Richter scale. What is known as a Richter scale and state its uses? The Richter scale is named after the American seismologist Charles Francis Richter. Here is an image of Charles Francis Richter. It is used to measure, that is, the Richter scale is used to measure the intensity of an earthquake. What is intensity? Intensity is the amount of energy released during an earthquake. So Charles Francis Richter, the Richter scale is named after, and the Richter scale is used to measure intensity, that is the amount of energy released during an earthquake. Very simple, Richter scale is a scale which is a 9-point scale, that is 1 to 9, and it measures the absolute intensity with mathematical precision. So it is a very precise scale. It has a total of 9 points, as you can see here. Final point, it is commonly used scale where each point upward. It is a commonly used scale where each point upward from 1 represents a 10-fold increase in amplitude of the shock waves. So as you go 1 point up, there is an increase in 10-fold times in the increase in amplitude of the earthquake waves. Thus, what does this mean? This means that an earthquake of magnitude 6 will be 10 times stronger than an earthquake of magnitude 5. Question number 12, explain the Mercalli scale as a tool to measure earthquakes. The Mercalli scale is also used to measure the intensity of an earthquake. It grades the earthquake on the basis of observed effects on a 12-point scale. So the Mercalli scale is a 12-point scale. So if we compare this to the Richter scale, you have two scales. Richter scale, Mercalli scale. Richter scale 9-point scale. Mercalli scale 12-point scale. Richter scale is the scale which is with more mathematical precision. Hence, it is more used as compared to the Mercalli scale. In case they ask you difference, here is your 2 points. 9-point, 12-point, more precise, less precise. Hence, it is more used more. This is used lesser times. Moving to the next answer, effects of an earthquake. It's from question number 14 to 22. Here we will be covering 8 destructive effects and 2 constructive effects of an earthquake. Let's see what does it say. In geological terminology, earthquakes are a part of endogenic forces and are regarded as constructive movements. So they occur below the Earth's surface and they are constructive. They are good. But from human point of view, earthquakes are regarded as destructive forces as they cause loss of property and loss to life. As we said, we will be covering 8 destructive effects. Let's see what are they. Collapse of structures, danger to human life, fire, landslides, course of rivers, submergence, tsunami, flash floods, all are explained in the coming pages. These are the 8 destructive effects which we will be covering as a part of our syllabus. Let's see the first destructive effects of a volcano. Collapse of structures. Human beings have settlements in active volcanic zones. Most of these houses and other structures collapse, creating a great loss of property. For example, very important, the Gujarat earthquake in 2001. Second destructive effect, danger to human life. How does danger to human life explain as a destructive effect of an earthquake? Many severe earthquakes in the past have killed hundreds of lakhs of people. They died on account of house collapse under the weight of falling trees, poles, or other structures. Landslides and floods also have caused earthquakes and also have killed many people. For example, The earthquake in Indonesia in December 2004 killed more than 2 lakh people. Third one, fire as a destructive effect of an earthquake. During earthquakes, fire breaks out as inflammable material is thrown out. Gas pipes, bursting of gas cylinders, damaged oil refineries, and live electric wires catch fire, and they damage life and property in townships and factory complexes. Fourth destructive effect, landslides. Here is an image of landslides as well. Landslides are predominant when earthquakes occur in hilly or mountainous region. For a landslide to occur, an earthquake has to occur in a hilly or a mountainous region. The shock waves during an earthquake destabilize the rock material. They destabilize the loose rocks, which leads to landslides. This damages the buildings and hampers the transportation. For example, the earthquakes in the Himalayas, the Alps, and the Andes causes landslides. Fifth destructive effect, course of rivers. Earthquakes have changed the courses of a river in the past. As a result, rivers have thus rendered many areas unsuitable for irrigation and agriculture. When a course of a river changes, it makes an area unsuitable for irrigation and agriculture. Here you have an image because of an earthquake. Rivers have changed their courses. Sixth one, submergence. The forces of upliftment and submergence have also caused submergence of coastal areas. Example, Dwarka in Gujarat now lies submerged under the sea. Here is an image of submergence. The place they have given you in the syllabus is Dwarka in Gujarat, which lies now submerged under the sea. Seventh destructive effect, tsunami. I've divided tsunami into 4 points because it was a big point. Number one, let's see the meaning. Here is an image of a tsunami. A tsunami is a large ocean wave that is generally created or that is generated by any disturbance that rapidly displaces a large mass of water. When a large mass of water, usually in a sea or an ocean, gets displaced or disturbed, a wave is created and large ocean wave is created. That is a tsunami. Such an ocean wave may be created because of an earthquake. It may be created because of a landslide, volcanic eruption, or meteorite impact. However, the most common cause of a tsunami is an undersea earthquake. Origin: the name tsunami is taken from two Japanese words, su and nami, meaning harbor and wave respectively, and tsunami means harbor waves. Global phenomenon, third at point, tsunamis are more frequent or are most frequent in Pacific oceans, but they are a global phenomenon. They occur where large water bodies of water are found, including inland lakes, where they can be caused by landslides. They can be caused by landslides, earthquakes, volcanic eruptions, or meteorite impacts. Example, the 2004 Indian Ocean earthquake triggered a series of lethal tsunamis in December 2004, killing approximately 275 people, making it the deadliest tsunami recorded in the history of the world. Eighth destructive effect of an earthquake, flash floods. Here is an image of flash floods. The debris produced during an earthquake blocks the flow of a river. The debris produced during an earthquake blocks the flow of the river. As a result, the river gets diverted from its original course. This diversion causes flash floods and causes damage to life and property. The strong shock waves damage dams and embankments and the water stored there spreads speedily and causes flash floods as well. Two constructive effects of an earthquake in your syllabus. The first one, energy release. The majority of earthquakes, as we know, occur around plate boundaries. As a result, the earthquakes help the earth release the stored up energy. This energy release helps the earth to be kept in good shape. Here is an example of energy release from the earth. Second one, landforms. On account of both vertical and lateral displacement of the earth's crust. Vertical and lateral displacement of the earth's crust. Earthquakes may rise or lower some parts, especially near seashores. We had one example behind, that was Dwarka got submerged. Here we have another example. The Sagami Bay of Japan was uplifted by 200 meters in 1923. Landslides triggered by earthquakes caused the formation of lakes, as has happened in many places in the Himalayan zones. Once more, landslides triggered by earthquakes cause formation of many lakes, as it has happened in many places in the Himalayan regions or the Himalayan zones as well. Moving to the final answer, predicting earthquakes. We have two questions here, question number 24 and 25. Let's see what does question number 24 say. Is it possible to predict an earthquake? Give reasons to support your answer. Earthquakes predictions in the past were left to astrologers and mystics. Today it is a respectable scientific pursuit. The Russians were the first to discover P and S waves in 1960s. We did these in detail, P and S waves in 1960s, on the basis of which predictions for an earthquake were made. These waves are still the only means available to seismologists to predict earthquakes. The theory of plate tectonics offers other means for prediction of earthquakes on scientific lines. So two ways, P and S waves. 1960s, Russians were the first one to discover them. These waves are still the only means available to seismologists to predict earthquakes. The other one is the theory of plate tectonics for prediction of earthquakes. Final question, question number 25. How do Japanese predict the earthquakes? Japanese use methods of measuring changes in sea level. Japanese use methods of measuring changes in sea level and the variations in Earth's magnetic field. To predict earthquakes, however, no method is still foolproof, as has been proved by recent earthquakes in Japan, India, and USA. This brings us to an end of the chapter.